Okay, we're live. So, good morning, good afternoon, good evening to everyone who's joined us on this webinar. I think we should wait maybe a minute or so to allow more people to join in, and then we can get started. So, please bear with us for another minute. Okay, I guess we're good to go. I see lots of people joining in. So, once again, good morning, good afternoon, good evening, depending on where you're joining in from. So, welcome to yet another Netdata webinar. I'm Satya, and today I have with me Rolf, our VP of Technology, and together we'll be taking you through OpenTelemetry and how we've added some capabilities within Netdata to integrate with OpenTelemetry. Uh, Let me just quickly point out to the agenda. We've gone through the introduction, so we're going to be talking about OpenTelemetry and how we've integrated that into Netdata, but also, to start off with some OTel basics for some of you who may have not yet be well versed with OTel. Um, what is the compatibility that we've built into Netdata for OpenTelemetry? How would we ingest logs, metrics, and traces eventually into Netdata just natively, but also some custom OTel collector pipelines. And then, of course, some bits on what's coming up, what's the immediate roadmap, and then finally concluding with some Q&A. Of course, don't wait for the Q&A section. Keep filling in our chat with all of your questions, and we will take them up as and when we proceed with this webinar. So without any further ado, Rolf, all yours. Let's start off with this webinar.
All right. Welcome, everyone. So let's just start with Netdata a little bit. So Netdata is a tool that originally started as a service you can install on all your laptops. It will have a lot of collectors that that will grab metrics from all the things that it can find, and that's how we grew for quite a while. At some point, we were like, oh, we should probably also ingest things from, let's say, more generic sources. So instead of just reaching out to the local operating system to find metrics or services, let's integrate what services themselves are advertising as metrics. For example, using the Open Metrics format, also known as Prometheus format. And so we could grab that as well. And there have been various standards like this. Before Prometheus, there was StatsD, and then people were like, okay, we also need something for logs, we need something for tracing. And then a lot of standards started to exist. Project started. Now, OpenTelemetry is basically a collection of both protocols as well as tooling to instrument your code, and also a collection of what they call semantic conventions that basically say, okay, well, if I have a particular attribute for a metric or a log entry, then I want to specify what it actually means when that attribute exists. And so those are the semantic conventions. Along with that, they also defined a bunch of tooling. So tooling in two ways. So one is you can instrument your code with an SDK. So you just reel in that library, and you have a bunch of tools that allow you to send metrics, send logs, etc. elsewhere. There is a protocol defined for this. It's called OTLP, the OpenTelemetry protocol, and that allows you to send it to another service. For example, for massaging that data, taking out attributes or enrichment, or to store the logs or metrics into a backend system. And one of those backend systems could be Netdata. And so what we did is we said, okay, let's do that. We're sending the OTLP protocol messages to Netdata, and then we will ingest them. For metrics, we will attempt to treat them as if they are from native collectors. And for logs, we invented a system to ingest the logs locally. Did I miss anything?
No, Rolf, we had a little bit of a glitch at the beginning where we lost the stream, but I think we
so the so-called OTel plugin in Netdata listens for the OLTP gRPC protocol and ingests logs and metrics. However, it does not do anything for you in terms of massaging data. So you cannot say, well, I want to add this attribute with this value, or I want to extract this piece of a message and put it in a separate attribute. It also doesn't allow you to, let's say, take metrics from logs. And so there's this other piece of tooling that the OpenTelemetry community created, which is called the OpenTelemetry Collector. Now, the OpenTelemetry Collector is a Go-based framework that allows you to create pipelines that go from, let's say, what they call receivers. So there could be a lot of sources. You could have a Prometheus source. You could have syslog. You could have some tracing source. And then there are so-called processors that you can use to massage that data, modify it to your liking, and then you can send it to an exporter. And an exporter could be, okay, I'm going to send these metrics to Prometheus, or I'm going to send the logs to Elasticsearch, or you can, in this case, also send it to Netdata using the same OTLP protocol, which the OTel plugin that we have added to Netdata includes. So the OpenTelemetry collector is not a necessary component of using Netdata to ingest your OpenTelemetry signals, but it is very useful to add some stuff. When you do ingest the metrics, they will be treated, as I said, as if they were native. So you can use them just as native collector metrics for alerting. There will be unassisted machine learning on top of every metric. You can ingest them at a 1-second interval if your source has that kind of granularity, and you can use the built-in AI features in Netdata Cloud to analyze all the signals as if they were from the native collectors. So what I would like to do today is to show you a little bit about what that looks like. How do logs end up in Netdata, and how does that look like in the user interface? So I will switch to this little thing.
Let me.
It's called the OpenTelemetry demo. It's an application that you can just run as a set of containers using Docker Compose, and it will set up a virtual shop that is very similar to real online shops. You can go shopping, and what you will see here is a bunch of items that you can buy. For some reason, it's all space telescope thingies. So I can, for example, have this great Eclipse Smart thing, and I can add it to a cart, and then I can have a shipping address, and then I can buy it, place the order. And all the bits that you would generally expect from a web application are in there. So there is a bunch of microservices, there's some Kafka in there, there is a database, and there is telemetry as well. So this is what I'm going to use as the thing to show you how that ends up in the data. And then just to give you an idea here, what we just did, all of the clicks that I made earlier, they show up here. So I have a service called front-end proxy, and you can see all of the HTTP access. There's a cart log message, but you can also see there was this Eclipse Smart Travel Refractor telescope that I bought, and you can see all of the steps. There's a checkout, there's email, and if I click on one of those items, for example, this one, and all of the structured information that was originally in the log message is available as an attribute. And so you can see that it's on a relatively old machine with i7 8550, etc. But so all of the attributes that are added by the instrumentation will appear here, and I can also use these fields to basically use as columns, or to put them here in the sidebar as a filter. So say that I wanted to have a filter on the service name, for example. I can say, okay, let me have that as a filter here on the sidebar, and then you can see all of the different services that are in this demo application, and I can say, well, give me only the logs of the product catalog. And you can see here, and I added some columns for the demo product IDs and names. So you can see all the things that for some reason were visible. If you go back to this demo view, the reason why they show up is because they are here as well. So all of that shows up, but I can also go to let's say the payment. Apparently I paid for something, and so this is the charge request. And again, there are a bunch of attributes in here that say something about that buy. So those are logs, and you can slice and dice this. What wasn't visible here, but is usually there. I expanded the view a little bit, but there's also a histogram that shows you all of the events. You can change how that looks. So for example, I can change this into the service name here, and then all of the log entries are colored by that attribute. So this is logs. Obviously, we also support metrics, so we'll show that a little bit as well. This is a view of the metrics in OpenTelemetry, and let me scroll up a little bit so you can see the table of contents. So all of the demo metrics emitted, so these are container metrics. There are some HTTP request metrics, and there are some automated requests as well. So for metrics collection internally. So it's not I disabled the load generation, so it's a little sparse here. But all of the metrics that you would expect from that demo application are just here, and allow you to also see all of the labels that are generated as part of those metrics. So, for example, the SDK language here is Rust. All of that is available. You can slice and dice the data just as like you would with native metrics. And because the OpenTelemetry protocol is so heavy on attributes, we just make them available, all of them as labels as well. And the way I instrumented the demo application to add the data as the receiver, as I basically added this bit. Here, I added an exporter in the OpenTelemetry configuration that is called OTLP gRPC /Netdata. It has an endpoint. This is the IP address of my server. That's running the Netdata. In this case, it's my laptop. And I'm not using TLS for this demo, so I made it insecure. And so this is where I define the exporter, and then I downward here somewhere. I added the exporter here as the exporter for the pipeline for metrics and the one for logs. And that's the only thing I did. I started up the demo application like you normally would with make start, and it was good to do. That's the demo application. The next thing I would like to show you, if I can keep going. Is there any questions that I should take up now?
Yeah. Rolf, first of all, do you hear me?
Not sure. Okay. Satya, did you see any questions?
No questions at this point, but I don't think you're able to hear me.
If not, right? I will just continue.
I mean, yeah, let's go to the next part.
So the next bit is how can I, for example, take syslog messages in? Netdata does not natively support syslog as a way to get logs into Netdata. And so we depend on the OpenTelemetry collector to do that for us. So what I'm showing here is a very simple configuration for the OpenTelemetry collector that sets up a single receiver. It's called syslog. I have to specify the location for this. And the reason is that the syslog protocol itself does not have the concept of time zones. And it doesn't even have years in the log timestamps. So it relies on some context to know how to interpret the timestamp. So in this case, my server is running in a UTC. In this case, it's a network device that will be sending the logs. And then I set up a listen address. I did not use the standard 514 port simply because usually the collector does not run privilege mode. And so just taking another port was the most easy way to get stuff in here. And in this case, I don't want additional network attributes. Specify the protocol. And the next step is that I transform that data a little bit. So instead of the field that is extracted called hostname, I will use the proper name in according to the OpenTelemetry semantic conventions called host.name. And so I do a little bit of massaging here to get all of that into a nice shape. And then I define what the exporter is. Just like in the other example, it will just send it to the local machine at this port and not use TLS by default. And then the pipeline is very simple. The receiver is syslog. I have the transform processor, and then I send it to OTLP and to the debug output of the collector itself. Now, and when I do this, I can ingest these log messages. So I set that up in a separate node. And here you can see that there is the server called var, and it gets logs from a remote device, which in this case is a Netgear switch. And it sends messages. So you can see here, it regularly synchronizes the clock. Now, and if I log into that thing, it should produce a message. And so if I go back here, you can see, there is a new user session. And for some reason, there are two components in the switch that log that message. But that's a implementation choice by them. But you can see these log messages popping up over syslog. The other thing would be nice is if I could count how often that occurs, that somebody logs into that that thing. And so I set up a little additional thing into the OpenTelemetry configuration that is actually running on the machine. It's a little bit more involved because I also extract some additional fields. But the thing I added was this part. I have a so-called connector, which can act as both a receiver and an exporter. And it receives log messages, and then it can count them. And then it emits a metric. In this case, the metric that we create is called ralphm.example.userConnected. And I have a little description for it. And then I say, only count log entries for which the body matches this regular expression. So it's the one for main login that has initiated for user. And now I should get a metric that will count 1 for every time that I log into the device. I hook up the account in the, oh, hold on. Network connection broke. I hook it up here. So besides the regular OTLP export for logs, I also added debug as an exporter so that it can get the log messages from here. And then I have a metrics pipeline that gets those and send them to OTLP. And OTLP in this case, again, still is Netdata. So what does that look like? If I go to the metrics section here, it now started counting. Counting the first thing is always difficult for any type of observability thing. So I will just log in once again. And for good measure, I will just log in yet another time. And then what you can see here is that it started counting it. And now you might be confused about the value here because it doesn't say 1. And the reason is that this chart will show you the rate of logins per second. And that is not as high. So I only logged in twice. If I would have a whole lot of those events, then it would start to be closer to a reasonable value. But you can see that things are being counted here. And I guess that is the end of what I wanted to show you. It's relatively simple to set up, and you can get all the metrics and logs in. And now you might wonder what happened to the other things that OpenTelemetry does, for those who are familiar with OpenTelemetry. So OpenTelemetry also supports things like tracing in particular, and a relatively new thing is profiling. We are in the process of adding support for tracing. From the protocol's perspective, a span entry in the protocol is very similar to a log message. It just has a few basic attributes that are similar, that are different, but for the rest, it's just a bag of attributes and values. And so, from the storage perspective, we are going to use something that's very similar to that for logs, and then on top of that, we will create a visualization. And I cannot see the slides, but I am sure that Satya can tell you a little bit about the upcoming stuff in our roadmap.
Yeah, I think, Rolf, you are probably not able to hear me, but I can. And I think the stream does also show up the slides. So yes, like Rolf mentioned, we have the distributed tracing coming up with the ability to look at spans, service dependency, anything and everything that you expect for a full APM toolset. We expect this to be available in a few months. So keep waiting. It is also going to be based on OpenTelemetry. And yes, so we are excited to show around a little bit. Maybe once we have an alpha version, and we would have another webinar specifically for tracing. But while we do that, and I think I see a bunch of questions already that I've lined up, and I would start putting them in. If Rolf, you can see my screen, hopefully, while I put them on the screen. So first thing was, okay, it's not a question, it's more a suggestion from Steve to best leave the time zone to UTC. Absolutely. It's only in some specific scenarios where you may need to set it to the local time zone, but always a good a practice to leave it to UTC. Rolf, do you hear me? And do you want to add something? Okay, I don't think Rolf can hear us yet. Just give me a moment. Okay, I've asked Rolf to rejoin. Just give it a moment. And hopefully he should be back here. Okay, Rolf, I see you're back and you hear me now.
Yeah, I do, and I hope that everything that I said and showed was visible.
Yes, it was visible, just that the two of us were not able to hear each other, or you were not able to see the slide deck. But I don't think we messed up too much. So
Okay,
I'm just beaming in some of the questions that came in, Rolf, on the screen, so you can take them up. I don't know if it's completely related to the OpenTelemetry webinar that we had. This may be a generic question, Rolf, but you, of course, used a bunch of tools. So how efficient are APMs like Uptrace and Jaeger?
I am not entirely sure how to say something about this. If the question is about, well, how does it impact the running application? Of course, if you add tracing, then a little bit of the processing as well as traffic will affect your application a little bit. In terms of you have to scope the stuff that you're running, and the messages that flow from that for the spans will have to be sent somewhere else. If the question is about how Jaeger and Uptrace then affect the backend, well, that depends entirely on what is receiving it. I don't think it's proper for me to comment on that point.
Yeah, I think, I mean, Vinayak, if you have a follow-up question or if you can be more specific, we can probably take that up. The next one is more, I think, a fun bit. Uh, it was about your demo, Rolf, and
Yes.
how can you get
Um,
data?
yeah. So in this case, the switch that I used was a Netgear GS1110. So 110 TP version 2. I bought it somewhere in 2015. It's a small little smart switch that happens to allow output of logs using SNMP. Using a syslog. So for syslog, that's really easy. If you're talking about metrics, we actually have a native collector for SNMP that is pretty advanced in the sense that we have maps from well-known OIDs to Netdata's concept of metrics, and so I can show that a little bit, but it's out scope of the OpenTelemetry discussion. It's a native collector. It doesn't use OpenTelemetry here, but yes, you can use SNMP sources for monitoring, and it will show up as a network device here dashboard.
Yes, indeed. And I think we'll have a more detailed webinar on network monitoring because we've also introduced network topology and net flows. So maybe we can take that up in there. But yeah, most
Yeah.
definitely we do have a pretty
Yeah,
complete monitoring
yeah.
solution.
Yeah, I can just briefly show the metrics for this switch. I would need to share again. So, Sanjan, let's see. Just as a brief.
Yeah, I am putting that on the stream now.
Let me find the switch here. Network devices. So this is the GS1110 TP. We represent it as a node, just like you would a server. And then here on the side, you can see all of the stuff that it outputs. So, for example, the see the total traffic. Always have to look where it is. Oh, here. So this is the traffic, and well, by default it shows it like this. But you can also, you can also switch, and then you can say, well, actually, I want it by some other. Oh, this is just one dimension. Hold on. This is the network interfaces. You can also look at. Oh, it's not what I was looking for. Hold on.
Yeah, I think it's in the network interface section and you are in a different section. Yeah.
Yeah, there we go. Traffic total. Yeah, so here you can group by interface, and then you can see the traffic for each individual network interface by port. So this is just one example, and we will go into that in a separate session.
Great. Thanks, Rolf. I think let me put this. Yeah, I don't think I need anything to be streaming. The next question is interesting. I think you're the best person to answer this, Rolf.
Yeah. So it really depends. So in the data, from a design perspective, likes the data to live as close as possible to where it was generated, and so the whole architecture of how the agents and the data cloud operate is that agents will get their data and make it available by default to Netdata Cloud, and then you can introduce things like parents. A parent node is something that kind of centralizes logs and metrics. And you set it up so it will handle the bulk of the load instead of the work machine agent. So if you deploy Netdata in a Kubernetes cluster, for example, what we do is we set up a Netdata agent for every node in the cluster, and then we set up a parent, and all of the agents will stream their metrics to that parent, and the parent connects to Netdata Cloud. For logs, our Helm chart recently added an OpenTelemetry collector for ingesting the logs for Kubernetes containers. And that runs as yet another agent that is responsible for just keeping the logs data. So what happens is that all of the logs from the individual nodes in the cluster will just send their log messages to that collector, and then it gets ingested. So 50 plus should be just fine. In terms of data sources, if you want a whole bunch of OpenTelemetry collectors, if that's the question, how do you manage that? I don't have a singular answer for this. It's a bit of a. I was in February. I was in the meetup in Brussels, and there were entire discussions on how you would need to manage that. I'm aware that OpenTelemetry has some tooling for fleet management, so that you can push configurations there. That has its pros and cons. For Netdata specifically, we are considering whether we should add Netdata. Add the collector to the Netdata distribution, so that it gets fired up immediately when you need it in your setup, and then let's say the way that you manage the agents then automatically also includes the OpenTelemetry collector. Then, of course, you have the question on how do you then manage the configuration of the OpenTelemetry collector, and that's something that we will eventually also support, so that you can do this just like you can dynamically configure all of the other collectors. You should also be able to manage pipelines. And we also have an item on our roadmap for fleet management in general. So that should cover there. I don't have any timelines, but that's the short answer. For generic collectors that live outside of the Netdata space, but you want to hook up to Netdata, I suggest following the guidance of the that lives in the community. I find it hard to give advice on that. Yeah.
Yeah, thanks, Rolf. Yeah, truth be told, the OpenTelemetry collector is now not packaged along with Netdata, so we don't yet have a way of managing those pipelines or the collectors themselves. But in the near future, when we decide to package them together, and the fleet management that Rolf was mentioning about, we would also then be providing a solution to be managing this fleet of pipelines, let's say. But yeah, no timelines yet. We know we are keen on getting this as fast as possible, but we'll let you know once we have more information on this. Thanks for that question, Vignik. By the way, the next one, Rolf, is about eBPF metrics.
So in general, I would say that everything that the OpenTelemetry collector supports, either with its standard distribution or the distributions that other companies create, would be supported. So anything that can be formatted, transformed into the OpenTelemetry protocol metrics are supported. And again, for eBPF specifically, there's no requirement for using OpenTelemetry per se. We also have eBPF support as a native collector in Netdata. But the answer in general is yes. It can be done either natively or using the OpenTelemetry collector as a source.
Yeah, I think you've answered that. The next one is an interesting question. It comes in from Jason again.
Well, so how should I say this? Instrumenting your code in general is a great idea because it gives you the most control over what kind of metrics, logs, etc., get output. I'm aware that there are other tools that allow you to, basically pull in an SDK that then, does that for you, or indeed using eBPF to do some of that. Netdata does currently not provide an SDK that you can hook in. So for now, the recommendation would be, if you are instrumenting your code, use the OpenTelemetry SDKs for this. And that then also includes more advanced instrumentation from outside, like I think you're hinting towards. So it's not necessarily that Netdata itself replaces that, but let's say industry tools that are all gravitating towards OpenTelemetry as a standard for exchanging these signals makes them compatible with Netdata, with our plugin.
Yes, indeed. So I have one more question there, Rolf, and I think you should take this.
Yes. That's the short answer. Yes. So the way that we've built our AI in Data Cloud is that we give it the tools to interact with all of the metrics and logs that are available to you in the UI. And so you can start an investigation or even a free-form back and forth discussion with our AI to ask it things like, hey, something appeared to have happened at its timestamp, usually at 3 a.m. And then I want to understand what happened. And then it will go out and try to find metrics and logs that might be relevant to the thing that you're discussing. And as you are discussing, if you provide additional follow-up questions, gradually it will gravitate towards that answer that you're looking for. It is pretty, I would say it's pretty amazing. We've heard back from customers that said, hey, we are doing this root cause analysis on this incident that we had, and we spend, I don't know, 2 or 3 days with a bunch of engineers to try and figure out what happened. And then when we concluded, we asked the same question to Netdata, and it came back with an answer within a couple of minutes, just by going through your logs, looking at the metrics. And the interesting thing I found in this is particularly in metrics, because the data is able to store and make available metrics at a 1-second interval. It gets a lot more signal than you usually get with other tools, where the collection interval is like 10 seconds or even 30 seconds. And a human will have a very hard time to digest all of that information at that interval over long periods of time. And so using AI there actually makes it much easier to find issues that you cannot even visually intercept. Of course, the machine learning that we also apply to each of the metrics helps, because we can also allow it to find anomalies based on historic data.
Yeah.
Yep.
Yeah, absolutely. So Netdata, in Netdata, we've created our own playbooks and workflows for different types of investigations. So it can correlate metrics, logs, and in the future traces and other data sources. But we also have an MCP, which you can also use to just natively integrate with the LLM of your choice. But we've definitely added in a bunch of workflows and playbooks that are just more ready to use than
Yeah.
having to create your own workflows
And
there.
the next step is integrating MCP servers that you have locally. So that's something that we're working on as well, allowing you to basically say, well, I have this ticket database or some other source, maybe your source code repository, and I want to use that as an input to this investigation as well. That will be possible in the near future.
Okay, I'll move on to the next question. There are a few more.
Yeah, you can answer this just as well as I can, Satya. Yes.
Yes. Yes, I mean, so I think as part of Rolf's sticking to the open telemetry topic at hand, I think Rolf was showing ingesting metrics, ingesting logs, but also creating metrics from logs. And all of this is possible. And as long as you have metrics within the data, you can create alarms. And when you have these metrics, you have those charts, which you can build your custom dashboards, but also the automated charts that we create out of the box. So yes, that's that's a big yes. Um, okay, the last one. If I were to wear my business hat, I would put that on the screen. I think the short answer is maybe you should switch to Netdata. But jokes apart, uh, uh, yes, I mean, of course, right? If we have more details on how you use CheckMK and what aspects of your monitoring that you find slow or not providing you a solution, we could just get on a call and see how Netdata can help in there.
Yeah, I just wanted to add support to the call there to always use UTC for your time. I agree. UTC is time.
Yes, I think for those who are obviously not in some of our customer calls, Rolf has been a major advocate of that. And we actually faced an issue with one of our customers where we assumed all logs to be in UTC, but it wasn't. And then Rolf had to make a minor change to his collector config.
Yeah.
I think that's all the questions I see for now, but uh, we can hold on for a couple of more minutes, guys. We promised for this to be 45 minutes, but we were happy to extend it to an hour. It's close to 50 minutes now. We wait for a couple of more minutes for any incoming questions. If not, you can always reach out to us on support uh, on our support channel. Send us an email at support@netdata.cloud or create queries in there. Or if you have generic questions about Netdata and the capabilities, reach out to product@netdata.cloud, and we are more than happy to get on a call or even just provide you the necessary information. Okay, as we wind up, so yes, I mean the whole idea of having open telemetry compatibility is to not have any of our customers vendor locked in, or creating a custom solution with Netdata. It's to basically align with the open standards and for us to move along with where the industry is moving. And I think as of now, we're pretty happy with what we've been able to deliver. But like we mentioned, there's more coming. We distributed tracing and some other functionality as well, which would embed all of the OpenTelemetry standards. Um, Rolf, any last words before we conclude this webinar?
Well, so a thanks there. Most welcome. Again, if you have any questions, just reach out, and happy to talk about your experiences with OpenTelemetry in general, and how we can make the experience together with Netdata even better.
Okay, then. Thank you, guys. Have a great rest of your day, and we'll again be coming back soon later this month with our next episode on the webinar. So thank you very much. Bye bye.